anyway, so the components, I mean, for the computer, I'm not going to be talking about those in details, because I'm assuming that you all know what are the main components of a computer. However, there's some of the things that we're going to be working with when we are programming, or basically we're working with those CPU and RAM, because every time we're going to store something in the memory, this is the RAM is going to be used. When we perform some operations, some additions, some whatever operations that we do, it is sent to the CPU. So we're going to be working not directly through them, because now we're going to be using some high-level languages to program. Before, at the beginning of the computers, they were using some very low-level programming languages, which are very complicated to understand, because they have some language which is not the machine language, but something very close to the machine language. So basically, what we would like to be doing in this course, we would like to be sending some orders to the computer, so the computer can be doing things for us. However, the computer speaks a language, we speak another language. So in order for two different people to understand each other, they have to speak the same language. So what we need to be doing, we need to speak the same language with the computer, which is when we are going to be having a common language that we need to be using. So this is one of the things. The other thing is that we humans are not communicating with another human. When we communicate with a human, that's intuitive. But even though not with all ages, we don't communicate the same way. When you talk to a small child, you don't talk to him the same way you talk to a grown-up. Because if you'd like to ask a small kid to do something for you, you're going to simplify the orders so he can understand clearly what he needs to be doing. While if someone who is grown up, you can just tell him something really short, and then he can understand you. Oh, this is what you mean, and then he can do it. So imagine now we need to send and discuss and send some orders to a machine, which is just a piece of hardware. There's nothing intelligent in it. This is just like a chair, but programmable, that you can put commands in it. So we need to simplify our thinking, and this is one of the major challenges for you as in this course, in the introduction to programming. You need to simplify your thinking, and I'm going to explain that more, inshallah. So basically, any application that we're going to be writing is going to be doing something like this: take some input, do some processing, and give you an output. All applications, actually, most of them, not all of them, most of the applications that you're using are using this type of model. They take an input, do some processing, do some work, and then they give you the output. Gmail, for example, you're checking your email, whatever email you're using, it takes as input your username and password, and then it does some checking, and then it brings you as an output. You can see all your emails, or you can send an email, and so on. So if you check your WhatsApp, you then enter the message, it goes to do something, send it to the server, wait to someone to connect so you can send it to him, and then it shows you that, okay, it was sent to the server. It gives you some output. So this is what we're going to be doing. But we're not going to be learning right away how to make inputs and processing and output. The first thing that we're going to learn, is the easiest one, is just to display something, to output something on the screen, which is very simple, and we're going to be doing that. Inshallah, today you're going to write your first program just quickly, but it's not like a big program, but just something that is going to be displaying on the screen a text that we would like to display. Inshallah, by the end of this class, I'll try to shorten this presentation so we can get to that point very quickly. So anyways, the motherboard is one of the major components, if it's not the major component in the computer, because it links all the different components in there. I'm not going into a lot of details about the RAM, the CPU, but something that you might need to know, because we might use that later, is that in the CPU, in the RAM is for storage. And by the way, there's two types of storages in the computer: the RAM and the hard disk. You know what's the difference? Why do we have two types of storage in the computer?
Some has temporary memory.
Okay.
One is
Permanent. So why don't we use just the permanent? You're right. The RAM is temporary, and the storage, the hard disk, for example, is permanent. Which means that if you take the electricity out, whatever is in the RAM is gone, but whatever is in the hard disk stays there. But then the question: why are we using something that if you unplug it, it goes?
but the hard disk, the data you plug in, that's something unique.
Well,
All the things you do in the computer, you need it to be saved on the.
so why do we need the RAM then?
You need both.
Why we need the RAM? Why? I understand you said for storage. Okay, I understand. We need to store something. Let's put it in the disk. Why do we need the RAM for?
It's faster for using the application stuff, like maybe.
Okay, the key word is fast, yes. Because the slowest thing in your computer, in your phone actually, the slowest thing in your phone is storage. Because it takes time to take the information from the CPU to send it to the storage, and from the storage to take it back to the CPU so it can be displayed or be processed. So the slowest thing in your computer is the hard disk. And if we had only a hard disk without the RAM, our computers would be very slow, even if you have like i27, not only 7. If you have whatever the biggest I you might have, the biggest processor you have, it's not going to be fast because most of the time, just waiting for the information to come. When the information comes, okay, and then wait for the information to be stored. And so this is the CPU is going to be just waiting the whole time. So that's why what they did. They just said, okay, let's come up with something which is fast, even if we unplug it, it goes, but it's going to be fast. So that's why all what you see on the screen, this is stored in the RAM, because the RAM is very fast. So that's why we need the RAM. And when we're going to be working on the programs, when a program is running, whatever you see is running, it's in the RAM. Well, most of the time, because there's something called virtual memory. But I'm not going to be talking about that. Anyways, so whatever is executed, that means it's in the RAM, because the RAM is fast, and that's why we want our applications to be fast. And the RAM is like a piece of a bunch of boxes. You have a lot of places when you can store things, and each box has a number. This is what I want to. That number they call the address. So this is how, let's say, we imagine this RAM, and we are going to be putting something in those boxes. Inshallah, we're going to understand more when we're probably in the middle of the semester. We're going to be talking about different data types, which has like arrays and something like that. So basically, this is how it works. A lot of different cells, and then we can put data in each of one of them. And for example, all whatever you find actually in the RAM, I mean inside of computer, is just zeros and ones, and we can have letters represented as zeros and ones. And this is something that there's a table, the standard table that they call the ASCII table. Do you know what this ASCII table is? An ASCII table is, well, maybe let's have a look at this. Which is a standard. Actually, this is the standard for American Standard Code of Information Interchange. This is what ASCII stands for. So what they did, because we can, inside the computer, we cannot send letters, but only numbers are inside, so they put some codes. 0 means this, 1 means that, 2, 3, 4, and etc. So there's something that are not printable. You cannot see them on the screen. So up to, I think, 32, this is when where it starts. You have space at 32, and then go ahead. You have like hexadecimal, octal. I'm not going into that detail, but this is the numbering that we know: 32, 33, and so on. Later on, I'll be talking about this hexadecimal and stuff. So they give each character, each symbol, to be more precise, because these are symbols and numbers. They give them a number, and this number is, I mean, in decimal. And if you type, for example, if you look for H is 72, and let me show you something that you might know. Calculator. If you have this calculator, you go to view and you have programmer view. In this programmer view, you can see something interesting because you can actually see the how it is going to be converted. So if I type 72, you can see this is 72 in binary 01001000. Or you can convert it by clicking on just binary, so you can see it clearly there. Decimal, binary. And you convert hexadecimal. If you look here, 72 we said, so is hexadecimal 48, that's why. Octal, so 110, so etc. So if you like to see, this is the how H, probably this is what they are showing here, 0100 and then 1000. So everything is in binary. And it is converted for our view, for us, because we see better, we work better with decimal values. But inside, everything is binary.
So this is like the computer language.
Well, the computer language is binary, zeros and ones. It understands only zeros and ones. And why? By the way, why just zeros and ones? Do you know why?
It's the first language in computer.
Why is it the first language? How comes that this is the first? Why just 0 and 1? Why not 0, 1, 2?
Easy.
Well, yes, but there's a more reasonable reason. I mean, there's a more understandable reason. What goes inside this machine is what? Electricity. What are the different states of the electricity? Different states of the electricity is either the electricity is on or off. On, 1, off, 0. So this is how they do it. And they put some code like they put some code like this, because this is the only thing that you can vary. So this is the code that you can have. So this is 0, 0, 1, 1, 0. So it goes at a different space. And just up to now, maybe if you have seen some ships that's that sail on the ocean, they sometimes when they don't have radio, they use those Morse code using something like with a light. They just turn it on and off. And just you can send messages like that. So anyways, this is these zeros and ones. This is the most basic information that we were using, and we call them bits. Bits, and don't mix up a bit with a byte, because a bit is 1 0 or 1 1, and a byte is 8 of those. 8 of them, you group them, you give them. It's 1 byte, yeah. And we're not talking in bits. When we see something, we download something, we see it's megabyte, kilobyte, gigabyte. So everything is in bytes. But because we don't want to have like big numbers. And this shows some examples of like 2 and 7. These are the representation, the binary representations of those values. This is in decimal and this is in binary. So everything goes to the RAM. If you type something from the keyboard, it's saved into the RAM and then sent to the CPU, and the CPU, if it needs to do something and then return the result displayed on the screen, it is going to the RAM again before it goes to the screen. So the RAM and CPU, they are discussing, they're exchanging a lot. So that's why we need something to be fast. If we were using the storage device like a hard disk as a RAM, it's going to be very slow. And by the way, maybe you notice something. Sometimes when you open many applications, when you have your RAM, let's say, when the RAM is full and you open more applications, what is going on? The operating system is going to take some applications and save them on the disk. That's why, if maybe you remember, you open an application that you were using like for 5-10 minutes ago, and then you forgot about it. You used some other applications, and then when you go back to it, when it happens, it takes some time before it shows up. Why? Because actually it is taken back from the disk, put on the RAM, so you can see it again. So just the time that it is taken back from the hard drive to the RAM, that's why you see it's taking some time to show up. By the way, your phones are your enemies. Just put them in your pockets, and then, yeah, in the pockets. I don't like phones in the class, especially when I'm explaining, because their phones are tricky. They call you, they flash, they vibrate. They want you to hold them. So don't put them even in front of you, because they're going to blink, do whatever they can to get your attention. Okay, so okay, let's go. So whatever this is, something that I would like you to remember is this: that whenever we are going to be given some orders to the computer, especially in the beginning, and this applies also to any software. Actually, this is a list of instructions that are ordered. A list of instructions that are ordered. That means there's an order that needs to be followed. This is not a list of instructions that can be scrambled. There's an order that needs to be followed. So this is very important to think about the order, because sometimes it's going to be give you a different result if you scramble the order. Let's say I would like to go. What are the instructions that you're going to give to someone who wants to go from this class to the masjid there? First of all, get out of the class, turn left, then turn left again, or maybe you might tell them, okay, keep going straight and then turn left, and then when you get out, turn right. So these are orders that need to be followed during this order. If I just don't follow the orders, then go and then skip the, or I mean swap the orders, then this is not going to be giving me the result that I want. So that's why it's very important to pay attention to the order of your instructions. And as we said, inputs, outputs. Check inputs, do something, give an output. Not all programs are like that, but most of them, this is how they work. So we're going to be using actually Java. Why Java? I'm just skipping this because I would like to talk about the programming. So why do we need, what are we focusing on learning Java? Well, one of the reasons, Java is simple. It is portable, which means by portable we mean that it can be used, the same code, you can take it and you can use it in different platforms. You can use it on a Mac, on a Windows, on a Linux. So whatever you take, just take the code and then it works. Theoretically, well, if you take just the Java code, because sometimes if you have some libraries that are not existent in the other platform, this is hard. But the Java itself, it works everywhere. And also it is one of the most commonly used programming languages. And Java was developed, initially from a syntax coming from C and C++. So if you're programming Java, you're going to find a lot of similarities with C and C++. And by the way, don't think that if you learn one programming language, you're not learning others. Actually, many different programming languages share a common syntax with the Java. So if you learn Java, you're going to learn on many other different programming languages. And this is, I took that from last year. I don't know if it's still available, but it's still the same ranking since last year. But this is how it was in last year. These are the most commonly, most popular programming languages. So Java and you see C is quite, and then you have C++, C#, Python, JavaScript, PHP, Ruby, SQL, MATLAB, and go on. Probably these are like Chinese names to you, probably because you don't understand all these. But these are all different programming languages. What is the difference between a programming language? Why do we have like so many programming languages? Well, each programming language has an objective. So some of them are faster because their syntax, for example, the way they are compiled is make it closer to the machine, or some of them they have the compatibility, the portability, so it can be ported to different systems, operating systems. Some of them have different objectives on how they can be used. For example, JavaScript is mainly used within a browser. So when you browse the internet, a page can have some JavaScript to allow some processing to be done on your side, on the client side, not on the server side. Anyway, different programming languages, they have different objectives, but they share the common thing, which is the logic behind it. The same thing. I mean, whatever we do, if we declare a variable somewhere where we store information in Java, well, we need to declare another variable if we need to use it in any other programming language. The concepts are the same, just the language differs. So these are the, well, some of them are discussable, you know, this concise. I mean, there's some more concise, but whatever. It's simple, relatively simple. It's object-oriented, which is something which is very important nowadays, because this is the concept of how you program, which is close to the real life. It's portable. I think this is one of the major advantages of using this, and it's free. Well, most others are also more or less free. Okay, so just let me talk about something. Why we say that Java is portable, why it can be used in different operating systems. Just you take the code, it will work in different operating systems. Because there are two types, I mean, there are several types of how we, from a programming language, how we get to the machine language. The most important thing is here that we need to get to with the zeros and ones, because the computer just understands zeros and ones. So how we end up with zeros and ones is different depending on if you use Java, which is using some virtual machine. I'm going to be talking about that. Or some other, Java is not the only one, like you have also C#, there's another one. Yeah, but next time just take, yeah, ask permission. So this more classical, like the C, for example, to give the example of the C or C++, this is how they are going to be prepared to work on a computer. The file that you typed using that language is compiled. Compiled means it is converted from the language to the machine language, let's say. But with the Java or other languages that are using like this, C# or other VB.NET, if you heard about those, they're using some virtual machine, which means they don't convert it to a set of binary that can be used by the machine. However, they use an intermediate code. It's not the Java code, it's not the machine code. It's something in between. Why something in between? Because actually you need on every machine to install Java so it can be understood. You just not take Java and then put it on a Mac and there's no Java installed on Mac and you expect it to work. It will not work. Because you need to install Java in Mac, you need to install Java in Windows, Java in any. When you install Java, this is installed. So this can understand, this is the intermediary between your file and the machine. So this is how they made it available, portable, because you can just take the file, it will be understood by any virtual machine, because the virtual machine is already installed on each of those platforms. You had a question?
Yeah, Doctor, some computers have Windows and they have Mac
at the same time, yes.
Is this, does it, the program that they use is a virtual machine, or does this?
No. Well, it depends. Well, it's possible that they might be using a virtual machine, but no, this is something different. They install, depending on how they install the operating systems, you can have different operating systems on the same machine. But then how you make it, this is depending on your resources and how you're planning your usage. So most of the time, the disk, they cut it in two pieces, let's say. They partition it. One part is for the certain operating system and the other one for another operating system. So you cannot use them both at the same time. And another way is to, after you have only one operating system, and then you install a machine, a software which is allowing you to have virtual machines. The advantage is that you can keep going, working on two different operating systems at the same time. The disadvantage is this is quite slower than if it was installed on the machine itself. But this is not what we're talking about. We're talking about the fact that when you take your file, a Java file, Java code, and then you take it to another computer, if Java is not installed, this is going to be working. But if Java installed, this is going to be working. You don't need to change anything in Java. With other programming languages, well, you need to make some changes. The code itself needs to be to be changed, even if you have that programming language installed on the other machine. So because the libraries are different. Sometimes the name of some of those libraries are different, and things like that. So, of course, the advantage is that it's portable. The disadvantage is slow, because the program does not work with the machine directly. It works with a program that works with the machine. So, of course, it adds some lag, which is not very significant. But if you are working with an application, if you try to develop an application where speed is critical, you would like to have the fastest thing that you might have, then Java is not your preferred programming language. You might go for something like C, because it's quite faster. So this is the idea behind this portability. So that's what they're trying to explain. If you have like a program Java and then you compile it, it's going to be the Java virtual machine installed on Windows is going to understand it, and the one in Unix, Linux is going to understand it, the Mac is going to understand it, because they have the virtual machine. But you need to install virtual machines in all of this. This is what they call the write once, run everywhere. Microsoft did something like this, I mean, with the .NET framework, so they copied from probably Java, but it's not as portable as that. But so I'm not going to go into this because I'd like to show you in the code itself, and I'm going to skip those. Let's have a look at your first program. This is like something very easy, and I'd like you to try to understand this. And this is a Java program. Actually, you know what? If you take this code, you look at it like this, it's very similar to a C++ code. Very similar, because it's almost the same. Anyways, but so what I'm trying to say when I say that is that now we are learning Java, but inshallah, don't be scared to look at other programming languages, because they are you are going to be able to just understand them very easily. So yes, this is how it works. There's a lot of keywords programming, and this is what makes it difficult, because you have to be careful and not misspell something, because you will have errors, it reminds me something in this slide, which is Java is case sensitive, which means lowercase and uppercases are completely different things. So if you make something lower, why it should be capital, then it's not going to work as expected. So I'm going to be talking some of the things from that slide here. So first of all, this is a program. A program, if you'd like to write it, for now, we're going to be just focusing. This is the code. This is the code that displays something on the screen. What I'm saying here, display hello world on the screen. That's what it means. All these lines, only to say display hello world on the screen. Well, this is how we need to be doing this in Java. But I cannot just type this line without the rest. The rest is important as well. And for the first weeks, I'm not going to be talking about these. Just, you need to know that, okay, it's not easy to write with the mouse. Just know that now these lines over here, they always need to be there. And inshallah, as we advance in the topics, we're going to understand more what these are and how can we change them, if we need to change them, and so on. But for now, this is how it needs to work. When we write something, we need to do this in this way. Notice that there are some of those parts. Yeah, this is every time we work with classes. What is a class? We don't worry about it. We're going to be talking about that, inshallah, maybe in the middle of the semester, when we're going to be talking about classes and object-oriented programming. But for now, just let's say this is the name of the program. Class for you is a program. And then method is something that we don't need to know for now, but this is where I'm putting my code, let's say. This is where I put my code. So the method here, the main method, because this is its name, it's called main. This is where the code is going to be written. And the code instructions, this is what I mean here. Okay, note something that we need to be using these braces, okay? And we open one, we close one, and we open another one when we close another one. So it's very important to realize that there are different types of those symbols. These are the curly braces, these are the parentheses, and these are the square brackets. I mean the brackets, usually I use just braces, brackets, and parentheses. Don't get mixed up, because each one of them have a different meaning. And when you use these blocks, when we use those braces, we define a block. What is a block? Well, it's something that when we open and we close, it's something that we can put inside of it something else. That's it. We have a block, we can have a block inside of a block, we can have a block inside of a block of a block, whatever. So you got the point. How do I specify that this is a block? When I open the curly brace and I close it, and whatever it's inside, this is a block. So as I said, for us for now, we're not going to be focusing on anything except this line. And when we are going to create some files, these are going to come by default, and the only thing that we need to be adding is this, whatever we need to be adding. And I'm going to show, inshallah. You're going to try it today, inshallah. Before you leave this class, you're going to have your first program written. Okay, so again, braces, parentheses, and brackets. Each of them have a meaning. We're going to learn them. Don't worry, inshallah. By the end of the course, you'll be able to understand all these in detail. So now what we're going to be doing, once we have typed our program, we save it and then we compile it. When we compile it, actually, means what compiling means, trying to convert from Java to the machine language. But what happens if you type something wrong? It cannot be translated to the machine language. So what would happen? You are going to see some error messages. It is going not to tell you exactly what is the mistake, but it's going to give you a hint of what might be the mistake. It will tell you, well, this line, it had a problem, and somewhere, well, this column in this line, or this place, there's something that I was not expecting. So it shows you where you need to focus to make sure that you didn't type something wrong. And then, when you run your program, when you finish, you run your program, you see if it gives the result that you want. And if it gives the result that you want, that's fine. If it doesn't, maybe you find, okay, there's no mistakes, everything you type is right, but the instructions are not okay. You need to change them, adapt them, whatever. That's why they say observe the result and adjust the program if necessary, because you might, for example, if you write a program to calculate the addition of two numbers, everything you typed is right, but maybe instead of addition you used minus. So the program is working in terms of translation to the machine language, but does it do what you want it to be doing? No, because it subtracts instead of add. So now you need to make it do whatever you need to be doing. So this is the cycle that you're going to be doing. Write a program, compiles, if there's a mistake you correct it, and then you run. If it runs, that's fine, you check it if it's working. Yeah, and then if it's okay, then you're happy because you finished your application and it does what you want to be doing. So yeah, this is the same thing. You compile, but we're going to be using something, discard. We're going to be using a programming IDE, I mean this integrated development environment. This is what IDE stands for. Integrated development environment, which is a program that will help you make programs. But how did they make the program that helps the program to be made? So they used probably a program to make a program that makes the program. So I don't want to get into the details on how they ended up doing that, but they used, I mean, at first it was really hard. Well, I don't know why this is showing, but it shouldn't. I have put online here two things, I mean, a couple of things. The recommended IDE, it is already installed on your machines, which is NetBeans. And there's also another one which is installed on your machine, which is JCreator. It's simpler, but it doesn't help you much. I advise you to use this one. And the link here, if you click on it, it is going to take you to where to download it if you would like to install it on your machines. If you would like to install JCreator, it's very important for you that you install JDK first and then JCreator version 4.5. Any other version will expire after a month. And this is free, and you can download it. It will work every time. This is enough, but if you find yourself you're some sort of you'd like to explore more, you can just download this, and it's like the full version. You have a lot of different things that you can do. And you can see you can program with a lot of different programming languages: C++, C, PHP, and Java, of course. But this is what you need, only this one over here. But when you download this, okay, does it? I think it includes Java. You can add. I think it does include Java, but I'm not sure. Java 7 are required for installing and running the PHP. Okay, that means you can download. Okay, you can add. I think it installed Java. I'm not sure. If it doesn't, or maybe this is. You can download Java or download the latest JDK with NetBeans. This is what you need to be doing. Okay, let me just maybe save this link. But then why JDK 7? Okay. You know what? Let's do something different. Let me change this from here. So in all these, you need to install Java JDK before. And let me put the link of that. And you can choose whatever you need to be doing. Okay, save it. So this is the NetBeans. It's already installed on your machines. So this is just if you'd like to install them on your computers at home. So how are we going to be using this? Okay, if you'd like to create anything in NetBeans, and this is very important, I'd like you, and then I'm going to probably stop here.